Okay, let's go ahead and continue where we left off. We're going to continue with rational equations, solving rational equations. Let's go ahead and go over example 5. As you can see, we have 10 over n minus 6, 15n over n squared minus 2n minus 24, minus 6 over n plus 4. Okay, as you can see here, I kind of started a little bit of the work. I had already started the video, and then the video kind of broke down and I had to restart. So I decided just to start the way it is already. Basically, the restrictions are where your denominator is 0, and it has to do with your domain. That's where we left off last time. Okay, so basically what you're going to do is you're going to get each denominator. So in this particular case, for example, if you see your denominator here, it's n minus 6. We're going to solve for n minus 6, and we say n cannot equal 6. We're going to get the other denominator, n plus 4, and we can see that n plus 4 cannot equal 0, n cannot equal negative 4. Then when you're going to do with the trinomial, n squared minus 2n minus 24, you're going to factor it out. Okay, when you factor it out, you get n plus 4 times n minus 6 cannot equal to 0. You set the factors to 0, and you kind of discover that the two factors or the two solutions that you have are exactly what you already had at the beginning with the original two other denominators. Okay, so your restrictions, I kind of labeled them in green. N cannot equal 6 and n cannot equal 4. Okay, now we're going to rewrite it down. I'm about to erase this, so make sure that you copy this. This is how we find the restrictions. Okay. Now, what second step is you're gonna find the common denominator. Now, by me just looking at the problem, I can see that this is n minus 6, n plus 4, and this one has the orange color here, n plus 4 times n minus 6. The LCD should be n plus 4 times n minus 6. Can I go ahead and erase this? I'm gonna continue there. Okay, so then my LCD here, n plus 4, n minus 6. I'm going to multiply each one by the LCD. So then I'm going to copy this 10 over n minus 6, and I'm going to multiply this one by the LCD, n plus 4, n minus 6. Okay, equal to, let me go ahead and copy my LCD, n plus 4, n minus 6, and I'm going to multiply by my fraction 15n over. We said we were going to put it in a factored form, n plus 4, n minus 6, minus, let me go ahead and write my LCD, n plus 4, n minus 6, multiply by your other part of the fraction, 6 over n plus 4. Okay, when you do this, and the reason why you're doing it is because you want to get rid of the denominators. Okay, so you can see here that n minus 6 is going to cancel out, and we get 10 times n plus 4 equal to, notice here, the n plus 4 cancels, the n minus 6 cancels, so you're done. You only have left 15n minus n plus 4 cancels. 6 times n minus 6. Okay, you do all this work just to get rid of the fraction. Okay, so now I'm going to distribute. Okay. Okay, so notice that I'm kind of running out of space. I'm going to distribute here. Let me go ahead and write it down on this other side. Okay, when I distribute, I get 10n plus 40. It's equal to 15n minus 6n plus 36 when you distribute. Okay, when you distribute here. Combine the like terms. There's no like terms on the left side, so I keep the 10n plus 40. It's equal to Well, 15n minus 6n, that will give me a 9n plus 36. Move the numbers to one side, variables to the other side. So I'm going to move the 9n. I get a 1n plus 40. It's equal to 36. Subtract the 40. And it's equal to negative 4. Okay. Wait a second. You cannot really box this answer, so you got to check it. You got to check that your answer doesn't happen to be one of your restrictions, but your restrictions happen to have n cannot equal 4. And I'm sorry, negative 4. And because in this case, the answer happens to be negative 4, then this problem has no solution. Okay, this is your answer, just a little 0 with a line to it, or you can write it down with words. No solution. This one has no solution because it's equal to your restriction. Now, let's just say you do have an answer. Let's just say n was equal to 1. You can check it. You just put it into the calculator and you check it and make sure that one side is equal to the other side, and your answer could be that one. Okay, example 6 will be left to you. I'm going to do one example here, and the other example will be left to you as well. We have solve literal equations for an unspecified variable. Literal equations are super important for students who are going to be taking more math, students who need to continue with calculus and so forth. And we work with a lot of variables. So you gotta have the ability to be able to solve for different types of variables. In this case, we wanna solve for a specific variable, and we want the capital B, which is this one. So I'm going to highlight it so you know. Okay, the first thing that I want to do is I want to get rid of the fraction. I have a 1/2. So then my LCD here happens to be 2. I'm going to multiply both sides by 2. So this side by 2 and this whole thing by 2. And when I multiply it by 2, I get 2a. It's equal to, well, this 2 is going to cancel with that 2. I get h, parentheses, capital B plus little b. Okay, now next, you can distribute if you want to. So you can distribute from here, subtract, solve for the big B. Let me go ahead and keep on highlighting my big B. But I can also do the opposite. Opposite of multiplication is division. So I'm going to divide here. 2a over h, it's equal to big B plus little b. And then subtract little b. So then big B is equal to 2a over h minus little b. And then this will be your final answer. Sorry about that, I mean to do that. So then that will be it in this particular case. When you come back to this other one, you are going to be trying to solve for y. So you have to eliminate the y or work with everything, all the rules that you have been working or using in order for you to be able to solve for y. Okay, let's go ahead and move on to quadratic equations. A quadratic equation in one variable is an equation that can be written in the form ax squared plus bx plus c is equal to 0, where x is a variable and a, b, and c are real numbers such that a cannot equal to 0. Okay. It's called quadratic. Let me go ahead and quickly go over the word quadratic. It's called quadratic because the degree of the exponent happens to be degree 2. Super, super important. From now on, we're going to be, everything that we call quadratic happens to be degree 2. Okay, we have some properties. Now, you were working with this property even though you didn't know that you were working with it. It's called the zero product property. This property says that if you multiply two things together and the product is 0, then one of the two numbers that you are multiplying it by has to be 0. Okay, so we have the product of a times b, it's equal to 0. Then either A is 0 or B is 0. Okay, so let's go ahead and do that. So then let's see. I got to put it into this format. A times B, the product. A times B. Okay, this is not a product. So I have to factor out a GCF. GCF happens to be X, so I can pull out that X. X minus 10 is equal to 0. And you can see that this is a product. Then this is like my A, and this whole thing is like my B. So then X it's equal to 0, or X minus 10 is equal to 0. So X is equal to 10, or X is equal to 0, yeah? And you were kind of doing that right now, okay? So now let's go ahead and check. If X is equal to 0, and I was to plug it in here, just to check it, then A will be 0, but not B, because 0 minus 10 will be negative 10. When I plug in the 10, B will be 0, but not A. So that's okay. Okay, let me go ahead and do B, example B. It has to be in the form, this form, A times B. Okay, it's not, so I have to make it look like that, and then the other side must be 0. Okay, so I'm going to distribute. That will be 4x squared minus 14x equal to negative 12. I'm going to move the negative 12 to the opposite side. 4x squared minus 14x plus 12. It's equal to 0. Okay, so the first thing that I have so far, I only have a 0 here, which is the same as this one. But I don't have the other side, so I got to factor it out. Okay, let me see. Let's factor. So then I have, let me see, will be 4 times 12. 4 times 12 will be 48. And we want the sum to be equal to negative 14. Okay, I don't know. What do you guys think? Okay, so then we have 48. Okay, the two numbers that will give us 48, it's negative 8 times negative 6. That will give me 48, and the sum will be equal to negative 14. Okay, so then I'm going to quickly factor it out. We can factor it out by grouping or by trial and error. Some of you guys can do it by trial and error. In fact, I like trial and error, but I'm going to do it by grouping in here because some students struggle with it. Okay, so I will do the 4x squared, and I'm going to replace these two numbers in place of that one, minus 8x minus 6x plus 12. Okay, factor by grouping. I can factor out the 4x, and I'm left with x minus 2. And then I can do the other one. So then I can factor out a GCF right here. It would be a 3. Let's see, negative 3. Okay, I think I'm doing something wrong. Let me go ahead and go back again. I think I am trying to do this too quickly and my things are just not working. Let me go ahead and go back one more time. Okay, so I'm going to replace it for x squared. I'm going to do minus 8x minus 6x, then plus 12. It's equal to 0. Let me erase this so I don't get it confused here. Then factor out a GCF. GCF, it's 4. What about the GCF over here? Okay, so this is what we'll have. We'll have the 4x squared minus the 8x minus the 6x plus 12. It's equal to 0. And when we group them, let's see, my GCF here, it's 4x That will give me x minus 2. GCF right here will be a minus 6. X minus 2. Okay, you can see that these two are identical. This is x minus 2, and then I will put the two things that are left for x minus 6. 4x minus 6 still has a factor, but it's okay. We can leave it that way in that form. Okay, so now everything's equal to 0. Okay, so x minus 2 is equal to 0 implies x is equal to 2. 4x minus 6 is equal to 0. Add the 6, get 4x is equal to 6. Divide by 4, x is equal to 3/2. So we have two answers. X is equal to 2 or x is equal to 3/2. And that will be our two final answers. Okay, you will be responsible for doing the last example. The last example will be this one right here. So that one will be left to you. If you have questions, make sure you ask me during office hours. Let me go ahead and move on to something that is called the square root property. Okay, the square root property says if I have a number, if I have a variable squared equal to a number, then I can take the square root of that number and then I can add the plus and minus sign in the front. Let's go ahead and get started. Okay, I see x squared is equal to 4. This satisfies the condition that one side squared, and then it's equal to a number. Okay, and so then I'm just going to say this is x is equal to plus or minus the square root of that number. So x is equal to plus or minus 2. I have two answers. X is equal to 2 and x is equal to negative 2. Now, is it possible to do it the way we were doing it before? So the question is, why can't I now use the method I was just doing right now, which is the zero product factor? Well, you could use the previous method. You know, you can subtract the 4 and you can factor it out. This is the difference of squares. And you can set them equal to 0. And you get the two same answers, yeah? These two are the same as these ones. You're welcome to do it either way. But the reason why we're asking you or introducing you to a new one, it's because it's not always possible to do it using the zero factor property. Okay. And so this is the reason why we need a new one, a new method to solve it. Okay, that it's called the square root property. Okay, so now let me go ahead and move on to example 2. For example 2, as you can see, we do have a squared, but be careful because this squared is this one right here. Okay, not the 2. I gotta get rid of that 2 that you see right there. So I'm going to divide by that 2 first. And then I get w plus 3 squared, it's equal to 4. So now one side squared, it's equal to 4. Okay, I'm gonna take the square root. Okay, w plus 3 is equal to plus or minus square root of 4. W plus 3 is equal to plus or minus the square root of 4 is 2. Now I'm going to get rid of this 3 here. This 3 that you see here, I'm going to subtract 3 from both sides. So subtract 3. And so then I get W is equal to negative 3 plus or minus 2. We're not done. We have two answers. W is equal to negative 3 plus 2, which is equal to a negative 1. W is equal to negative 3 minus 2, which is equal to a negative 5. My two answers are negative 5 and negative 1. There's no way out of this one. You must use this method if you want to be able to solve it. Otherwise, you're not going to be able to know how to do it. Okay, I'm going to start you off with C, and you are going to finish C on your own. As you can see, C doesn't satisfy the condition that I have. Now, if you start moving things around, you could try to subtract the 12 and see if it's possible to use the zero factor property, but it doesn't work. Okay, So if that's the case, then you are going to try to factor this trinomial. Is it possible to factor it out? And so that's what I'm going to do. Okay, I have 36 factors of 36 where the sum is 12. I know it is 6 times 6. 6 times 6 is 36 and the sum is 12. So I know that it will be x minus 6 times x minus 6. But x minus 6 times x minus 6 is the same as x minus 6 squared. So this is x minus 6 squared. It's equal to 12. And you should be able to solve it from here. Okay, so this one's for you. You got to finish this one here. Okay, make sure you solve it, and then you can ask me during office hours if you need to. Let's go ahead and move on to completing the square. Has something that is completing the square. What we want is a perfect square trinomial. I'm giving you two examples. I'm going to refer only to one because of my time restriction. As you can see, we have x squared plus 10x plus 25. If I was to factor it out, this will factor out as x plus 5 times x plus 5, which is the same as x plus 5 squared. And this is what we call a perfect square trinomial. And that is what we want. Now, what we want is, how can we create our own? Okay, what if I want to create my own perfect square trinomial? Okay, so in order for us to create our own, okay, my expression has to be a binomial. It has to be two terms, okay? And the leading coefficient here has to be 1. If it's 1, then I'm going to get the middle term, which is 18. I'm going to multiply 18 by 1/2, always by 1/2, and I'm going to square that number. So half of 18 is 9 squared. It's equal to 81. So I'm going to add 81. As you can see, I'm creating this like a trinomial. And now I'm going to factor it out. But in order for me to factor it out, it will always be the number before I square that will work. So I'm going to copy this number and I'm going to put it in here. So it's going to be x plus 9 squared. That's it. You will be creating your own perfect square trinomial. Okay, so let me go ahead and do the last one. Okay, the last one, we have a -7, and it's important for you to understand that sometimes the numbers are not nice, okay? Like this one. It does satisfy the condition of a 1 here, but look at that -7, okay? So I have a -7 multiplied by 1/2 squared. Well, this is -7 over 2 squared. I get a 49 over 4. So I'm going to add the 49 over 4 over here. This gives me my trinomial. Now I'm going to set it equal to, it's the number before you squared. This is the number before I squared. So I'm just going to copy this one. I'm going to put it in here. Okay, so then in this case, we're using y. So this will be y minus 7 over 2. And this is it. That's it. So we can work with fractions if we need to work with fractions. Okay, why is this important? Well, the reason why it's important is because we have to be able to know how to solve problems by completing the square. So here are the steps. Divide both sides by a to make the leading coefficient of a1. Isolate the variable terms from one side of the equation. Complete the square, and then apply the square root property to solve. Okay, I will do one example. You will be responsible for the other one. So I will do example B, and you will come back and we'll do example A. Okay, so here we go. Okay, the first thing that I want to do is I want to check to make sure that my leading coefficient is not, it's 1, but it's not a 1 here, right here. I have a -2. So I'm going to divide everything by a -2. Divide, 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 and then divide. So that's going to give me x squared positive 3/2 x, positive 5/2 equal to 0. Second step, I'm going to move the constant. I don't want it here, I want it on the other side. So it's going to be x squared plus 3/2 x. It's equal to a negative 5/2. Okay, now, as you can see, I'm creating these two terms right here. Those two terms, I am trying to make them look like right here when we were working with this expression right here. And did you kind of notice that we started with two terms right here? And then we started working our way from here. Yeah, we started with these two terms right here. And then we kind of made it a perfect square trinomial. And that is what you're going to be doing. So once you do that, you are going to create your own perfect square trinomial now. So, okay, so in this case, I'm going to get the middle term number. So this is 3/2. I'm going to multiply 3/2 by 1/2. And then I'm going to square that number. Well, this is 3/4 squared. That gives me a 9/16. Okay, so I'm going to add that 9/16. But if I add a 9/16 on one side, I must add the 9/16 on the other side. Okay, so now I'm going to factor the left side. And it's the number before u squared. This is the number before u squared that will go in here. Okay, so then that would be x plus 3/4 squared. It's equal to, using your calculator, go ahead and do the 5/2 plus the 9/16. And that will give you, let me go ahead and try one more time on mine. Okay, I get negative 31/16. Yeah, I'm going to take the square root on both sides. X plus 3/4, it's equal to plus or minus the square root of negative 31/16. Okay, then I am going to subtract the negative, I'm going to subtract this part right here. Okay, so then this is going to be x is equal to negative 3/4 plus or minus the square root of negative 31/16. I don't know what the square root of 31 is, so I'm going to write it down like this: negative 3/4 plus minus square root of negative 31 over square root of 16 is 4. Okay. At the current time, because I have a new symbol that you guys have never seen, which is that negative. Because of that negative inside at the current time, this will be a no solution problem for us. But once we talked about complex numbers, we will be able to do that. In fact, let me go ahead and do that now, since the video will be ready soon. Once we talked about, yeah, I'll just leave it like that. I will come back to it later. Okay, let me go ahead and move on to one example of the quadratic formula, and then I will end the video right here. We have something that is called a quadratic formula. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. The proof is in the book. And the thing is that it's kind of tedious to be completing the square every single time. And so we have to be very thankful that we have this formula. Okay. And so let's go ahead and start. Okay, so basically what we're going to start is, remember that the quadratic equation, it's in the form ax squared plus bx plus c. This is a quadratic equation. And you can see your a here and your b and your c. So it has to be in this form And the other side has to be equal to 0 in order for you to be able to see what the value of A is, what the value of B is, and what the value of C is. Okay, so I'm going to do example 15 and you will do A. Okay, so as you can see, example B, it's not reading in this form, so I have to put it into that form. So I got to move the 15 to the left side. So this is going to be x squared minus 2x minus 15. It's equal to 0. Now I'm going to compare them. So I can see that my A, I don't have an A here, but I do have a B and I do have a C. Okay. So then I can see that my A has to be equal to 1 if I don't have one. And B is -2 and C is -15. I'm going to plug those values into the formula. Okay, so you need your formula right there. So let me go ahead and input them into the formula. Okay, so then the formula says, in this case, it's x, it's equal to -b. I'm going to look at the b. It's -2 plus or minus b squared. It's -2 squared. Sorry, I can't really write my 2's in here. -2 squared. A minus 4 times A is 1, times C is -15, over 2 times A. And A happens to be 1. Okay, now, using a calculator, you are going to input this piece first into the calculator only, the way you see it. Please go ahead and do. And when you do, you should get 64. So then this is x is equal to -2 plus or minus square root of 64 over 2 times 1 is 2. Okay, so now you are going to enter the numerator the way you see it on your calculator. I'm sorry. Let me go ahead and take that back. Your calculator is not going to be able to do this. You are going to separate into two answers. We have a -2 plus square root of 64 over 2. And then you have -2 minus the square root of 64 over 2. So notice that I'm kind of separating the plus and the minus, okay? So I have the plus here, and then I have the minus over here. Okay, so now we will input the numerator, okay? So make sure you're following this. Go ahead and input this first into your calculator. And when you do, you're supposed to get 10. And then put divided by 2, and the answer will be 5. Go ahead and do the same on the second one. And you're supposed to get a -6 over 2, which is -3. So you have two answers, 5 and -3. Now, just in case I never went over the radicals, in order to input a radical into your calculator. Now, your calculator can only do, cannot simplify radicals. There's calculators that can and some calculators that cannot. Okay, so the square root of 64 in your calculator, if you're struggling, you press the second key, and then you press the x squared key, and then you input the 64, and then you press the equal sign, and that should give you 8. Or you can do it in your head. The square root of 64 is 8. Okay. Let me see. What do we have left to do? Okay, so in this particular case, this is the place where I am going to stop. For the other types of equations, it will be nice to do those in class. We really do need to do these ones in class or during office hours. So please see me after. Have a great day. Bye.